Hi guys, BuildZoid here, and welcome to another episode of GPU Necromancy. Today we've got this thing right here. This is a Sapphire R9 380 2GB compact card. That's part of the name. It's not like compact card, like there. See, compact. That's the name. Yeah, it's basically like an ITX R9 380. I got it off of eBay for 16 quid as 4 parts not working. And originally it was no display output. And when I'm looking for dead GPUs to try repair, I look specifically for cards with no display output. Because if the card is artifacting, there's probably nothing wrong with the PCB and everything wrong with the silicon. So because of that, if it's artifacting, it's a big no for me. Also, like, the other thing is, like, GPUs that are artifacting, like, people perceive them as less broken than GPUs that have no display output. So artifacting cards seem to go for higher prices than cards that don't have display output, which is just like, which is really stupid in my opinion, because artifacting card, like, if you have a card with an interposer and it's artifacting, it's probably completely dead and impossible to repair. And it's basically it's only worth as much as the parts are worth. Which can be quite a lot, right? Most of the HBM cards use pretty nice components. But yeah, so I avoid art, but yeah, like, on the other hand, like, you're probably never repairing one of those if it's artifacting, because there's probably something wrong with the interposer, so have fun with that. But with like, more normal cards, you can still have problems where it's like, well, if you reflow it, it'll work for 3 months and then it'll stop working again. I actually also have GPUs where if you just there's also GPUs where if you just fiddle with, like, the mounting pressure, they'll start working and then stop working again. So yeah, I don't like GPUs that artifact because they're not in any, like, I don't really consider them repairable. You can get them into a condition where they run, but how long they're going to keep running for is totally, like, unknown. You know, there's no guarantees how long they're going to stay in a running condition. So I prefer to look for cards with no display output, because if there's no display output, you can still have a card where there's something wrong with the silicon or the FCBGA or the BGA, and then it's, like, not really repairable again. But you can also have straight up just, like, component failure elsewhere on the PCB, and then it's just a matter of finding the offending component and removing it, and either replacing it with a, working replacement, or doing what I usually do, which is to just kind of go around the problem, which is what I've done with this card. So let's take a look at the actual repair, or I think calling this a repair is being very generous to me, but it does run, and I'm not like, if I had to run this in my daily system, or more like, if it weren't for the fact that my daily has an RX 580 in it, I would I'd be totally cool with dailying this. But yeah, I didn't buy this card to daily it. I bought this card so that I can, like, repair it and then mod it and bench it for 3D Mark. So yeah, I'm not too concerned about the longevity of this repair, though. I really don't think there's, like, I I don't think there's anything wrong with that. My biggest concern is that this linear regulator came off of a dead 7970. So this is not like, and I'm kind of worried that I might have cooked the regulator when I was taking it off the 7970. That's, like, my biggest concern here. Is I'm not too concerned about the fact that this isn't the way this was supposed to be getting power. Like, this isn't how it's supposed to look. My biggest concern is, like, I might have damaged that chip that I put there. Anyway, so what I've done here is, this is a 5-volt linear regulator off of a HD 7970, and what it's doing is it's providing the drive rail for all of the power stages. Because the issue that this card had was there was previously a little buck converter here that would generate the drive rail, which I believe Sapphire normally has that at 6 volts. I don't have schematics, and the drive rail wasn't working. It was at 0 volts, so I don't know what it was originally supposed to be. But either way, power stages also run just fine on 5 volts. In fact, they're primarily designed to run on 5 volts. The whole idea being is that you can just take 5 volts from your, 24-pin. Like, if you're making a motherboard with power stages, you could just take 5 volts. from the power supply, shove it into your power stages, and ta-da, they work, they run. Isn't that amazing? You save yourself the trouble of adding extra voltage regulators to the motherboard just for the sake of powering the VRM. GPUs, unfortunately, do not have a 5-volt rail coming into them anywhere. The PCIe slot only provides 3.3 volts and 12 volts, and the 8-pin only provides 12 volts. So if you want to run power stages on a GPU, you gotta generate your own drive rail for them. And Sapphire, in my experience, like most of the Sapphire cards I have that use power stages, don't run 5 volts. They tend to run 6 volts, which helps a little bit with the VRM efficiency. But theoretically there's a reliability trade-off to that, though I'm not sure how how much of an effect running the power stages on 6 volts has compared to 5 volts, especially since the IR3553s that are used on this card are, the documentation for them even says, is actually spec'd in 6 volts. It's just kind of yeah, you can also run them on 5 volts if you want, or even 7. 7 is sort of the upper boundary of what you can run them on, at least according to International Rectifier, so, yeah. Anyway, so this is slightly lower voltage, so the VR might be is going to run slightly less efficient, but the most important thing for me is that the VRM does indeed run, because previously it didn't, because there was 0 volts there. So now we have 5. In terms of how this is wired, the black wire is pulling 12 volts from an input filtering capacitor for the VCore VRM for actually sort of all of the VRM. Or most of the VRM. No, I think all of the, I think there's two 12-volt power planes. But anyway, input filtering capacitor for 12 volts, and I've just grabbed 12 volts off of its leg, and that goes to the linear regulator. The tab of the linear regulator is supposed to go to ground. So I have this piece of wire. Actually, we could zoom in on that. Let's see. Oh, that's actually pretty centered. Ta-da! Oh boy. Overdid it. Oh wait, no, it managed it. Cool. So yeah, this piece of wire just goes over to these capacitors. That's ground over there. And then I also have a second piece of wire going to ground over here. So I have sort of 2 ground connections going to the tab of the linear regulator. Mostly because I subscribe to the idea of you can't ever have too much ground. And yeah, I wasn't sure if this was going to be enough. It shouldn't be a problem, but there's also no harm in having extra ground connection points. So yeah, especially since this is taking ground off of the actual output filtering capacitor for the drive rail, so this one's probably better. And other than that, I also repurposed the pad that was originally used for the inductor to hold the linear regulator in place. So yeah, that thing isn't going anywhere. It's very, very solidly on, which is basically my main concern with doing anything like this, is making sure that components are attached in such a way that you can put the card down on the desk like this, and PCB down, and it doesn't break whatever you attach to the back, because the thing is, if you have if you attach extra capacitors to, say, multi-layer ceramics or something, what tends to happen, if you put any stress on that connection, there's a decent chance you're going to rip the cap, the end caps off of the multi-layer ceramic capacitors, which is bad. You don't want to do that. So yeah, I've used the inductor pad that was originally there, and that inductor pad is now just being repurposed for holding the LDO in place. And then this is the output leg of the LDO, and that just goes to the previous, the output pad of the inductor that used to be there. And yeah, that's kind of it. That there now, 12 volts comes in, gets converted to 5 volts, goes to the power stages. Power stages are now happy because they run on 5 volts, so they can turn on. The troubleshooting process for this was it took really long. Way too long, because I initially assumed that the inductor that was down here is for 12-volt input filtering. So for the longest time, I didn't bother to check if there was any voltage on it. which basically led to the fact that I spent like I think a couple hours like measuring things and going like, oh no, this is working. Um, like this rail is working, that is working, all of this isn't working, and I'd keep like power cycling the card to see if anything would change because I already knew there wasn't any short circuits. So that's like the first step with any GPU or motherboard repair is check that there aren't any short circuits, right? Because if there are short circuits, the last thing you want to do is the last thing you want to do is turn it on. So yeah, I did check that there weren't any short circuits, but I kept kind of power cycling it. It's just like trying to see if like anything was changing. Trying to catch if any of the regulators was like turning on and then quickly turning off because some of them will actually like with some cards that is a thing that you run into like a rail will turn on and then shut down again. um yeah, so I spent forever doing that, and then I just kind of got the idea, you know what, screw it, let's just check every single inductor on the card and if there is a voltage on it. Because the thing is with inductors is they're either being used for input like power filtering. So like you just have a inductor in series with like the 12 volt power, like with the 12 volts going to the power stages, or you have them as part of voltage converters. In which like, and in both cases, right, in both applications, the inductor will have a voltage on it relative to ground, because I've never seen a inductor go from ground to ground. Um, I guess if you were trying to isolate different ground planes on something, then you might do that, but I've like literally never run into that. So under most circumstances, an inductor that has 0 volts relative to ground indicates that whatever is like connected to that inductor is not working or isn't connected. So yeah, eventually, you know, once I just tried to measure every single inductor on the card, I came to this one and was like, wait, this one's at like all the other like, you know, the VRMs were at 0 volts, which was like, well, of course they are. And then I got to this one, which I was like, oh, that's totally 12 volts. And then it's like, wait a minute, there's 0 volts on that. And then I noticed the little chip next to it, which I've seen that chip before on a GTX 1080, where it was also used for, I believe, generating a 5 volt rail. And I was like, oh, that's probably the drive voltage for the power stages. Um, and so at that point, what I did was I checked if that inductor is connected to the VCC pin of the IR3553 power stages. I'll link the data sheet to the IR3553s down in the description, so you'll know which pin I'm talking about. But yeah, there's a VCC pin that gets connected to 5 volts. Otherwise, the power stages don't turn on. And so I checked the inductor to the VCC pin of one of the power stages, and well, it was connected to absolutely nobody's surprise. And I was like, okay, so we just need to replace that dead buck converter with something that produces 5 volts. Other options include, because yeah, here what I did is I stole a linear regulator off of a HD7970 to generate the 5 volts. But honestly, I could have also just like gotten a Molex power connector and used 5 volts off of that. Right, like you could just take a Molex, like you could just take Molex, 5 volts from a Molex or from a SATA connector. Um, so yeah, lots of options. The main goal was just like get 5 volts to the power stages somehow, and once you do that, bam, card turns on and runs. So yeah. Oh wait, no, there's a few more things I wanted to talk about. Now, with the linear regulator replacement that I did here, my biggest concern doing this was that this regulator wouldn't be powerful enough for the power stages. But the IR3553 datasheet basically says that they pull like tens of milliamps. So this 5 volt half amp regulator should be just fine. And I also stress tested the card for like 7 hours of running Firestrike, and I checked the temperature of that linear regulator, and it was sitting at like 70 degrees Celsius on the default fan profile. So evidently, it's just fine. It wasn't overheating. It ran for 7 hours without any issues. I'm going with this is totally acceptable. I'm actually really surprised that Sapphire went with the buck converter, considering that, because yeah, there's so many cards where they do just use a linear regulator for generating 5 volts for the VRM. Like that's a very normal thing to do. And then there's this card where like this isn't even that substantial a VRM. There's not that many power stages. There's only 5. And they're like, yeah, let's do a whole freaking buck converter. I'm like, what? Why? Um, Oh, and then you get like NVIDIA cards where there's like 3 different 3.3 volt power linear regulators, which is really weird considering you do get 3.3 volts from the PCIe slot, and then NVIDIA is just like, yeah, and add 3 more of those onto the PCB itself. Anyway, yeah, so now this runs, because we got 5 volts, and that regulator is fully capable of providing the necessary amount of power. For the card to function. Now, the other thing I wanted to point out is this right here, because on the current, like the I'm not on the latest AMD drivers, but the relatively modern drivers that I have on the GPU benchmarking OS that I use on the, like, that I've been using with the 5950X for benching GPUs. Yeah, I don't have any voltage control for this card, which is very weird because it does use an IR3567B, and that should be a very like well-supported controller in most overclocking utilities. So either Sapphire blocked access to the 3567B, which would make a lot of sense considering this is an ITX card. You wouldn't necessarily want to shove a ton of power through it. Or the AMD drivers are being the AMD drivers and blocking voltage control, which wouldn't necessarily surprise me either. Though with Sapphire, like there's a lot of Sapphire cards where for whatever reason you can't talk to the controller. But luckily for us, Sapphire does give us these 3 solder points right here, which are for connecting the I2C header to the voltage controller. So yeah, I'm just gonna hook up like with these 3 points. Like I could use an Elmore Labs EVC, or what I'm gonna actually use is I'm probably gonna use the Infineon USB 005, because I've done well with the USB 005. I can potentially like flash the firmware on the card, like flash the firmware of the voltage controller to potentially unblock it in software. I'm not sure. Like it depends what I like. Depends what I end up seeing when I connect to it. Otherwise, I might just like use it to set a permanent voltage offset. That's another option. Because the thing is, I can use the AMD drivers to lower the core voltage. I can't raise it. So I could just permanently set the core voltage like 200 millivolts higher, and then whenever I don't want all of the voltage, we can lower it in the software. Because yeah, this is a bench card for me, so I don't really like, I don't need it to be in a practical, usable state. Now that I say that and hear myself say that, it's like, Buildzoid, this is why every time you turn on, like there's a whole set of GPUs I have. It's like this is why every time you turn those on, you need to check which BIOS version they're on. Because I have such a like, because that approach of like, we'll just do something weird to the firmware and then forget about it works great while you're like benching the card, and then when you come back to the card like 3 months later, it's like, the hell is it doing? Why is it doing this? Who did this? Is it broken? No. It's just what you did last time you tried to bench it and then promptly forgot about. But anyway, yeah, I can get voltage control on this thing with that header. So thank you, Sapphire, for that. Let's get the card in the system. There we go. Oh, I guess I should also, I might have to bypass the fuses now that I think of it. Though I don't know how much those fuses are rated for, so maybe it'll be fine. Like for when I want to bench the card, I might have to bypass the fuses. Because yeah, I really want to get like 1200 plus core on it. The air cooler on it is actually surprisingly capable. Also, the card has dual BIOS, which is like, this is honestly a really nice card considering that it's just like a little ITX thing. The heatsink's good. It's got dual BIOS. It's got an I2C header, which the I2C header is mostly like a standard feature of custom Sapphire PCBs. Most like Sapphire PCBs will make it pretty easy to find that header. But like if you compare it to say reference AMD GPUs, reference AMD GPUs are a nightmare because on reference AMD GPUs, AMD likes using these really like high pin count connectors. So, and then they like to have several of them, right? It's not enough, like, so here for the VRM controller on this card, there's one connector. and it's very easily identified because it's 3 little dots near to the VRM controller. On AMD reference cards, you have like rows of pins for like for debugging headers, and somewhere in those pins there's probably an I2C connection to the controller, but they have fun figuring out which pins it is. So anyway, yeah, here we are in the OS. It's an R9 380, 2 gigs. Apparently it has Samsung VRAM. I don't know if that's good for 380s or bad. I guess we'll find out when I get around to benching it. I mean, my initial impressions are that the VRAM is actually kind of terrible. Doesn't go, like, I think I tried to run it at 1650 and it already started, or actually maybe just 1600 and it already started artifacting, which is pretty disappointing. But yeah, I have like tons of mods planned for this. Also, the VRAM voltage controller is like a Richtech RT81020, I think, which should be very, very easy to volt mod. Though at the same time, I kind of suspect, like, I think a lot of the Samsung GDDR5 doesn't even necessarily scale with voltage. So while it might be easy to mod, it might not do anything. Yeah, because that happened to me with the RX 480. Or the memory overclocking is limited by the memory controller. And in that case, we'll just have to overvolt the memory controller and hope that I don't blow it up like all the other times. Actually, there was only one time. Yeah, yeah, it was only one time that I blew up an AMD GPU memory controller. Well, now we get a chance to make it a second time. Yeah. Anyway, so yeah, Firestrike's running just fine, as you can see. And I gotta say, this heatsink really did surprise me a lot. Like, I thought, like, with a heatsink this small, my immediate assumption was, like, this is going to be hot and loud. But it turns out, during that 7-hour stress test that I ran, on the stock fan curve, it tops out at, like, 2200 RPM, which I consider pretty quiet. And the reason I say I consider it pretty quiet is because I've come to the conclusion that I probably have a much higher noise tolerance than most people. Probably because I don't like being in quiet rooms. So 2200 RPM, in my opinion, is actually very quiet. But yeah, it tops out at 2200, and the card sits at 70 degrees Celsius, which is, like, that's good. That's really good, as far as I'm concerned. And if you bump up the fan speed to 3000 RPM, at which point I do think it's kind of loud, it sits at 60. And that isn't even the limit for the fan speed. Like, you can crank the fan even higher. So, yeah. I'm really impressed by the heatsink on this card as well, considering how small it is. So that's kind of it. We're just gonna wait for Firestrike to finish. It is at stock, so it's not gonna produce some crazy score. Well, the 5950X still really lifts the overall score hard on a card like this, but yeah, it's not going to be the best. So yeah, I now have a working R9 380. Whoa, this score is even lower than the last time I ran Firestrike. I wonder, probably just variance. But, yeah, so that's it. Let's turn it off. And, I guess, thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. The links to both are down in the description. And yeah, that's it for the video. Thanks for watching, and goodbye.